So in this problem, a bullet of mass m is fired into a block of mass big M. So I have the mass of the bullet, small m, the mass of the block is big M, which is initially at rest. So this one has a speed at the beginning 0, while the bullet, it's moving at a certain speed. So let's call the speed of the bullet VB, okay? At the edge of a frictionless table. So the table has no friction. At a height h. At a height h. He gave it to you here, okay? The bullet remains in the block, and after impact, impact means like collision. It's similar to the collision, okay? After the impact, the bullet remains inside the block. So it will penetrate inside the block, and they will become like one big block plus the bullet inside it. So the block lands to a distance from the bottom of the table. So the block will move, of course, it will give the block some momentum. Okay, so the block will move as a projectile until it reaches to the ground here. What is the initial speed of the bullet? Okay, what is the initial speed of the bullet? Assume that m is 99 small m. The big M, the mass of the block, equals 99 m's of the bullet. Okay? And neglect air resistance. So this problem has two parts. The first part is conservation of momentum. When you fire the bullet to the piece of wood or to the block, we should conserve the momentum. I will say what? The total momentum before collision equals the total momentum after collision. Before collision, I have the mass of the bullet times the speed of the bullet plus the mass of the block times the speed of the block, but the speed of the block is 0. It was at rest. So this part is 0. Equals, the bullet penetrates the block and they move as one block. Let's say their speed after the collision or after the impact, I will call it V prime. So after the collision or after the impact, the total momentum is what? The mass of the bullet plus the mass of the block times V prime. This is the velocity after the collision. But he told me that the mass of the block is 99 m's. So 99 m, which is m plus 99 m, that's 100 times m, of course, times V prime. So we can say mb times vb equals 100 m V prime. I'm looking for what? I'm looking for this one, the speed of the bullet. So the speed of the bullet equals, and actually m bullet m, it's m. So we can remove this m with this m. So it's easy to say VB equals 100 times V prime. So this is the first equation. That the speed of the bullet equals 100 times the speed of the two objects after collision, which is V prime. Then what is the second part of this problem? The second part is the block. The block now with the bullet inside it. They have a mass now, as we said, it's 100 m. But we don't care about the mass in the projectile. They have an initial speed. What is the initial speed of this projectile? It's V prime, because this is the initial speed of the projectile. Then it will reach to the ground here. It made a horizontal distance d and vertical distance h. We need what? We need a relation between the initial speed and the h and the d. Those three variables. Let's remember the equations of the projectile. X, the horizontal distance, equals the initial speed. We used to say Vi, but here I will say V prime times t. And the distance x here, he called it d. Okay? So this is the first equation. I will use it. The second equation, Vy equals gt. I don't need it. The third equation, h equals half g t square. Oh, that's important. The last one, Vy square equals 2 times g times h. I don't need it also. So I will cancel this one and this one, but I will use the h. H equals half times g times t square. From this equation h, I will say what? I can say t equals, I will take the half to the other side, it will be 2. So it becomes 2 times h, and the g will go to the denominator on the other side over g, and the t here is squared. So to remove the square, I will take the root. Let's make it a root. The square root. So the time equals 2 times h times g. Take this time and substitute it in this equation. D equals v prime times t. So d equals v prime times t, and t is what? Root of 2 times h divided by g. We are trying to reach to v prime. So I will get v prime, then I will substitute it in the first equation here to get the bullet speed. So v prime equals what? Take this root to the denominator on the other side. So I can say v prime equals d divided by this root, which is 2h over g. I can write it again as what? This is the d. And g here is in the denominator of denominator, so it will go to the numerator. It becomes g over 2h. Okay, guys? So this is v prime. Take this v prime and substitute it back in the first equation here. So I would say what? So the speed of the bullet equals 100 times this term, which is d times root g over 2h. G over 2h. It's not exactly in the answer. In the answers here, he put the d inside the root. So I will take the d inside the root. I will write it d square. There is nothing. There is no problem. Then let's look again. Which one is the right answer? 100 times g times d square over 2h. So the first one is the right answer. Okay, guys, it's a little bit long, but it's worth to do it. Okay, so at the beginning again, conservation of momentum. Total momentum before equals total momentum after. So I reach to a relation between the speed of the bullet and the speed after collision. This speed after collision will be an initial speed to the projectile. Then I will make the equations of the projectile. This is the horizontal equation, and this is one of the vertical equations. Okay, I got the h as a function of t, then I will take t and substitute it back again. So I get a relation between d and v prime and h and g. Okay, then I will take v prime in the left hand side alone and everything to the right hand side. Then I will plug it back into the first equation here, and v bullet will be this term. Okay, thank you so much.